This is notes for 5.6, derivatives of inverse trig functions. So none of the 6 trig functions is one-to-one, meaning that they're not going to pass the horizontal line test. And also not one-to-one means that their inverses are never going to be functions on its own. So to create inverse functions, their domain must be restricted to a convenient one-to-one interval covering all the ratio values. So if we think about the sine curve, and if we look at the inverse sine curve, then normally it should continue past these points here. But in order to allow this to be a function, it would have to be restricted. The domain has to be restricted so that it will pass the vertical line test. So if we stop if we stop the value at pi over 2 and negative pi over 2, then the graph is now going to remain a function. All right, so arc sine and sine are inverse functions of each other. This means that the arc sine of x is equal to x, and sine of arc sine is equal to x. So this is just properties of inverse functions. If we take the composite of one into the other, they're going to cancel out and just and the only thing remaining would be just x. So since f of f inverse of x equals x, then sine of arc sine of x equals x, or sine of inverse sine of x equals x. All right, so these are just using inverse properties to show that two functions are inverses of each other. All right, so here are the inverse trig derivatives. We have arc sine, arc tangent, and arc secant. These are the three distinct ones. So arc sine is u prime over square root of 1 minus u squared. Arc tangent of u is u prime over 1 plus u squared. Arc secant of u is u prime over absolute value of u times square root of u squared minus 1. And then arc cosine, arc cotangent, and arc cosecant are just going to be negative versions of corresponding arc trig functions. So arc cosine is just basically the negative version of the arc sine. Arc cotangent is opposite of arc tangent. Arc cosecant is opposite of arc secant. So really, if we know these three rules, then we essentially know these other three corresponding rules. Just to kind of talk about patterns here, arc sine and arc secant are the only ones with the square roots. Okay, arc tangent is the only one that that does not have a square root. They all have u primes up in the numerator. Arc tangent has the one that's 1 plus u squared. The distinction sometimes is hard to do between arc sine and arc secant. Arc secant is the one that's more complex. Now, to kind of help remember the order of the 1 minus u squared or u squared minus 1, arc secant has absolute value of u and the square root of u squared minus 1. For arc secant, the u's are next to each other, so that will kind of help remember, help you kind of distinguish between arc sine and arc secant. Arc secant is the one where the u's are next to each other, which means that arc sine must be slightly different from this, so it's square root of 1 minus u squared. All right, let's look at example 1. These are just problems that we need before we get into derivatives here. So it says find the tangent of arc cosine of root 2 over 2. Now, arc cosine of root 2 over 2, another way of expressing this is this represents an angle. All right, so another way of writing this is cosine of what angle is equal to root 2 over 2. Okay, so this problem means find the tangent of the angle whose cosine is root 2 over 2. So the steps that we can take to step through this problem is we need to draw a triangle and label the angle theta. We always start off with the right triangle. Label the sides according to arc cosine given. So angle is root 2 over 2. Angle whose cosine is root 2 over 2. So we can label the angle as theta. Cosine is root 2 over 2, so cosine is adjacent over hypotenuse. So adjacent is root 2, hypotenuse is 2. So if the adjacent is root 2 and the hypotenuse is 2, then we can use Pythagorean Theorem to find out the opposite side, which is also root 2, because root 2 squared plus y squared is equal to 2 squared. If we solve for y, we get root 2. So once we get root 2, now we can figure out the tangent of this angle, tangent of this theta here. So tangent of theta is simply going to be opposite over adjacent. So opposite over adjacent, root 2 over root 2, which is equal to 1. Okay, number 2, find the cosine of arc sine of 5 over 13. So we can first start off by creating a triangle, right triangle here, theta, and then we can figure out for what theta is sine equal to 5 over 13. All right, so 5 over 13, sine of theta would be opposite over hypotenuse. So 5, sine of theta equals 5 over 13. So in order for this to be true, 5 has to be the opposite and 13 has to be the hypotenuse. So once we have 5 and 13 as the opposite and hypotenuse, we can figure out the adjacent by going to the Pythagorean Theorem. Or this is a Pythagorean triple if you remember this 5, 12, 13 triangle. But we can do y squared, 5 squared plus x squared equals 13 squared. Solve for x, we get 12. And then once we have this, then we can find the cosine of this angle. So cosine of theta is simply now going to be adjacent over hypotenuse, so 12 over 13.